Hello class, let's start our lesson today with a review on what is division. Division is the process of dividing a number or set of objects into equal groups. We can also think of division as how many times does the second number fit into the first number. If we wanted to find out how many groups of 3 are in 9, we could set up our problem as 9 divided into 3 equal groups. So I'm going to draw 3 circles on my whiteboard. Then I'm going to take the 9 and divide it out into these 3 equal groups. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I look in each of these groups and I see that there are 1, 2, 3 dots in each of them. So I know that 9 divided by 3 is going to be 3. And we see that with the dots in our 3 equal groups. I also want to review fractions. Fractions include a numerator and a denominator. And in order to help us understand this, I have a pizza right here for you. I've cut this pizza into 8 different slices. 1, 2, 3, 4, 5, 6, 7, 8. Each of these slices are going to represent the denominator in our fraction. The pizza as a whole would be one whole pizza. So one whole. We have 8 slices as a denominator. And then the numerator, the number on top of the fraction, we are going to think about how many slices we have. So it's cut into 8. We have 8 slices right now. But if I was to eat a slice of pizza or simply take one away, try to get this out. Took a slice away. Now I have 1, 2, 3, 4, 5, 6, 7 slices of pizza. My numerator, or the number of pieces that I have, would be 7. And it would be 7 out of 8 because I cut 8 pieces originally, and there's a piece missing right here. So it would be 7/8 are represented by this pizza as a fraction. So put this away. Before we start getting into our lesson, let's try a real life example involving whole numbers and fractions. So a story problem involving whole numbers and fractions. The story problem is that 2 cups of flour makes 2/3 of a batch of bread. What we need to find out is how many cups of flour would be in one whole batch. So 2 cups of flour makes 2/3 of a batch of bread. How many cups of flour are in one batch? So the first thing I'm going to do is draw a rectangle to represent my batch of bread. So I'm going to draw a nice rectangle. And I'm going to label this as one batch. So I have one batch of bread here. Okay, then now I want to consider, so we want to find out how many cups of flour in the whole batch. I want to consider what do we know already? What do we have? So we have that 2 cups of flour makes 2/3 of a batch of bread. So I'm going to look at the bottom number of the fraction. The denominator is going to tell me how many slices of pizza or how many sections do I have to split this bread into. So I'm going to go straight down. Straight down, I have it in what should be 3 equal sections. 2/3, so I can shade in 2. The numerator tells me how many I get to shade in or how many I have. Think back to the pizza, how many slices of pizza we had. So 2 of these slices of bread, or 2/3 of the batch of bread, would be highlighted, shaded in just like I did. And 2 cups is what this represents. It says that 2 cups makes 2/3 of a batch of bread. So this is 2 cups. Now we want to find out the remaining portion of our batch of bread. So if 2 of these equals 2 cups, then I can tell by if this is 1 cup and this is 1 cup, then this one needs to be 1 cup as well. So 3 cups of flour would be what we need to make 1 whole batch of bread. And we were able to do this by dividing up the 1 batch of bread, shading in what we know, and then figuring out what we didn't know by using what we knew. So I'm going to erase this. Okay, then the next story problem that I have for you is that Billy has been having a great time at the arcade. The newest Star Wars video game requires 1/4 of a credit to play for 1 whole minute. Billy has 7/8 of a full credit left after his long battle at the video arcade. How long can Billy play the Star Wars game with his remaining 7/8 of a credit? So first I want you guys to try this on your own and I will show you. So first we want to ask ourselves, how many groups of 1/4 are in 7/8? So how many groups of 1/4 are in 7/8? Again, let's draw some pictures to help us out. First we want to draw a rectangle that's going to represent a whole credit. So this is 1 whole credit. And we want to fill out a part that we know within the story problem. So it says that the Pod Racer game requires 1/4 of a credit in order to play for 1 minute. So 1/4 of a credit gives us a minute. So the bottom number, or the denominator, the amount of slices that I cut up in a pizza, is going to tell me how much I need to divide the whole box or credit rectangle into. So I'm going to put it into 4 equal pieces. And then it says that 1/4 of a credit allows Billy to play for 1 minute. So I'm going to shade it in. And then this equals 1 minute. This 1/4 of the whole thing is going to tell me that 1 minute. So now let's consider, what does Billy have, and try to create another 1 credit rectangle to represent what Billy has now. And it says Billy has 7/8 of a credit. So what I want to do is to compare it to what I have up top, because this is my reference. This is what I know. That 1/4 gets me a minute. So what I'm going to do is I'm going to put this into fourths as well to help me use this as a reference. I'm going to make these lines a little bit thicker. Making these a little bit thicker. So now, so that when I go back, and I see that the bottom number here is 1/8. So now I just need to take a line in between, and this will get me to the 1/8. I have 1, 2, 3, 4, 5, 6, 7, 8 sections, and we need to fill in what Billy has, how many slices of pizza there are. So I'm just going to fill in 7 of these, shade in 7 of these. rectangles. And this is what Billy has. Now I can take a look up at my reference point. I know that a fourth of this gives me 1 minute. So 1, 2, or where that thick line goes, is 1 minute. And I see another thick line here. 1, 2, another minute. 1, 2, another minute. And then this one, now both of them are shaded, so this is only going to be a half of a minute. So this is half a minute. Okay, so now that I have used this as my reference, I can now add these up and see how many minutes Billy gets with his 7/8 of a credit. So I have 1 minute, 2 minutes, 3 minutes, and then he has a half a minute. This box is going to represent a half of a minute. So 3 1/2 minutes is what Billy has to, that is how long Billy can play on that Star Wars game. So that is our answer for our little warm-up and review activity. Going to erase this. Now what we're going to do is we're going to look at dividing fractions by using fraction strips. So I have some fraction strips here, and I want you guys to use your fraction strips as well. You should have a bunch in a bag. First thing that we're going to try to find out is one whole fraction strip divided by 1/4. My question for you is, what does the denominator tell us? So it should tell us how many pieces, like the pizza was cut into, how many pieces are required to put together to get a whole. And then how do we know what fraction strip pieces to use? Well, we're going to know that by looking at that bottom number and seeing that because we're dividing the whole by 1/4, that we're going to be looking for 1, 2, 3, 4 yellow pieces together. 4 yellow pieces together. And we're going to see how many of these fit onto the whole. So I'm going to set this up. I've got one whole, got 1/4, another 1/4, another 1/4, and then one more. Now what I need to do is I need to count these up. So I have 1, 2, 3, 4. So that's going to be my answer. When I divide it up, I get 1, 2, 3, 4. So I'm going to write this down. So 1 divided by 1/4 equals 1, 2, 3, 4. 4, the whole number 4, or this also means as a fraction, 4/1. It's the same number. It is the same number, just written different ways. We're going to try to look for a pattern as we continue to do this. So just pay attention to this once we get towards the end. Our next problem that we're going to try is 1 whole divided by 3/5. So again, it's important to ask, what does the denominator mean for us? So to 3/5, so you're going to have to try to find your fraction strips that when you put 5 of them together, 1, 2, 3, 4, 5, that 5 of them together equals that whole. And we can always test that by putting it back by the whole. Seeing that it's the same length, so that means we have the right ones. This is how you know you got the correct one. 1, 2, 3, 4, 5. Okay, but we're taking one whole, and I'll even write this out, one whole divided by 3/5. This is what we're going to try to find out with our fraction strips. So what we have to do is use these fifths. These are all fifths, but we're using 3/5. So we're going to put 3 of them together. Now they can come apart, but we want to kind of pretend that they're together. This is one whole piece, because when they're together, this is a 3/5, and that would be a whole 3/5. It'd be 1 unit when these guys are together as a 3/5. So we're going to use these to measure, using only 3/5 at a time. How many of these does it take to get to this? So we're dividing it like this. Okay, and then I'm going to take another 3/5. I'm going to put it right next to that ruler. Put it on top. See how many it takes until we reach the whole ruler. So we reach the whole ruler, and remember these got to stay together. So it should look something like this. So now what we want to do, we want to count our 3/5. Now remember I said you want to act like these are together. Act like these are one solid piece that can't move. So this is going to count as one whole, as we put it next to the whole. So this is 1 3/4. So I have 1, and then I have, it's not quite 1, but it is 1, 2, 3. There's 3 total, but there are 1, 2 out of 3 that reach the 1 unit. So I need to consider this as 1. This is my 1. And then I'm going to use this as a fraction. It's going to be 1, 2 out of 3 pieces. Because there's 2 pieces here. There's an extra. 1, 2 out of 3. So 2/3. So I could write this as 1 and 2/3. Now another way that I could write this is a mixed number. I want to write it as an improper fraction so we can continue to see this pattern. So we could write it as this, or remember that 1 would also be considered 3/3. If we're looking at this number, try to get these to be like terms. So we're taking away that whole 1, making it 3/3. It's the same number, just going to be easier with this. And then we're going to add the extra, the 2/3. So 3/3 plus 2/3 is going to equal, and we go straight across, 5/3. So this is either 1 and 2/3 or 5/3. This would be important for later. So now we have another one that we're going to try out, another fraction strip example. So I have my 1 whole again. Now I'm going to take my halves. We're going to take 1 whole. So 1 divided by 3 halves. We're going to find out how much is 1 divided by 3 halves. So again, I have some halves. I have 3 of them. I'm going to try to consider this as a full piece. Consider it as 1 whole piece together. Now I'm going to see how long is it compared to my 1 unit. It looks like I have 3 total pieces. 2 of them are covered. So 2 pieces out of 3. So when I divide it, it's going to equal 2/3. Okay, so now what we're going to want to do is we're going to look at what we've done. Let's see if we can find a pattern. And I want you to find a pattern between that 1 divided by 1/4 equals 4 over 1. 1 divided by 3/5 equals 3 or 5 over 3. And that 1 divided by 3/2 equals 2/3. So I want you to take a close look at the fractions and then the answers that we've got. You should see that when you take 1 divided by a fraction, the answer is the fraction but flipped. So they get flipped. The numerator went to the denominator. The original denominator went to the numerator. So they got flipped. When a fraction is divided by 1, you can see that it gets flipped. And that is called the fractions, this specific fractions, reciprocal. We're going to be focusing on reciprocals today. Reciprocal is when two fractions are multiplied together and they equal 1. I will show you an example using some of these reciprocals that we just found out. So we found that 1/4, and then our answer was 4 over 1. When you multiply straight across, you get 1 times 4 equals 4. 4 times 1 equals 4, and that's going to equal 1. When the fractions get flipped, they're called the reciprocal, and reciprocals always, when you multiply them together, equal that 1. They equal 1. So I want you to, I'm going to give you an example of a few reciprocals. I'm going to give you some examples of a few fractions. I want you to write the reciprocal. There are two very important rules as we start to write our reciprocals. First, you need to write the number as a fraction. So if the number, for example, is 5, you need to write it as 5 over 1. So 5 turns to 5 over 1. Next, you need to flip the fraction. So the numerator is going to go to the bottom, denominator is going to go to the top. When you flip it, you get 1 over 5, and that's going to be the reciprocal of 5. First put it into a fraction, then you got to flip it. So I'm going to give a few examples here. 4/5, the reciprocal here, after you flip it, it's going to be 5 over 4. They are just flipped or reversed. 7, find the reciprocal of 7. First, we're going to have to put it into a fraction, 7 over 1. Then all you got to do is flip it. That's going to be 1 over 7. You can even find the reciprocal for mixed numbers. If you have 1 and 1/2, first we need to put this into a nice fraction. Right now it's in a mixed number, we're going to put it into a fraction. So we know that if our bottom number is 2, that's what we're going to stick with. We're going to stick with that bottom number. We're going to turn 1 into 2 over 2 because that's the same thing. And then we're going to add the 1/2 that's left over, which equals 3 over 2. Now we have it as a nice fraction. All we have to do is flip it. Now we have 2 over 3 as the reciprocal of 1 and 1/2, or 3/2. So that's going to be the reciprocal there. Okay, now I want to show you this chart. It shows you some division and multiplication equations. On the division side, it says 10 divided by 10 equals 1. Multiplication side, it says 10 times 1/10 equals 1. I want you to look for patterns as I continue to read through this. See if there's any patterns. 10 divided by 5 equals 2. 10 times 1/5 equals 2. 10 divided by 2 equals 5. 10 times 1/2 equals 5. 10 divided by 1 equals 10. 10 times 1 equals 10. 10 divided by 1/2 equals 20. 10 times 2, or 2 over 1, equals 20. 10 times 1/5, or 10 divided by 1/5 equals 50. 10 times 5, or 5 over 1, equals 50. 10 divided by 1/10 equals 100. 10 times 10, or 10 times 10 over 1, equals 100. I want you to look at this chart. What patterns did you see? And is there any way we could avoid using division in these equations and still get the answer using multiplication? So is there a way we could avoid division and still use multiplication? So what happens is we have the division on this side, and the multiplication shows its reciprocal. So 10 and then 1/10. So it showed the reciprocal. So instead of using division, we could multiply using the fractions reciprocal. There are some important steps that we need to follow when you're changing a division problem into a multiplication equation that has either a whole number divided by a fraction or a fraction divided by another fraction. So first, we want to keep the first number the same. If it's a whole number, keep it the same. If it is a fraction, keep it the same. Change is what's next. Change the operation from division to multiplication. From division to multiplication, you change it. Third, you flip the second number. Flip the second number. Flip the fraction. And then finally, multiply straight across. It is important to know that when you're dividing a fraction by a fraction, you can use the keep, change, flip, but you multiply the first fraction by the reciprocal of the second fraction. So that first fraction is going to keep it the same. Change it to multiplication, and then flip the second fraction. Now I'm going to show you an example. So we're going to take 1/4 times 1/4 divided by 1/5. First thing we're going to want to do, keep this fraction the same. So 1/4, change division into multiplication, and then we're going to want to do a flip. Get that reciprocal. So we're going to flip the second fraction. That's going to get us 5 over 1. Now all we got to do is multiply straight across. 1 times 5 equals 5. 4 times 1 equals 4. This is going to tell us the answer to 4, or to 1/4 divided by 1/5. After we've done that, after we've flipped it, we've kept the first number the same, changed it, took the reciprocal, and got this answer. That's going to tell us the answer to the division problem by using some multiplication. Okay, now you'll be working on the activity sheets that I've given you. You're going to be working on a variety of problems and equations that have to do with dividing and multiplying fractions by fractions. Okay, now that I've given you enough time to complete the activity sheets, I'm going to give you your exit ticket for today. So grab out a piece of paper. The first question and problem for our exit ticket is going to be looking back what we did for our review or our warm-up for today. The second question, it was Billy has been having a great time at the arcade. The newest video game, Star Wars Pod Racer, requires 1/4 of a credit in order to play for 1 whole minute. Billy has 7/8 of a full credit left after his long battle at the video arcade. How long can Billy play the Pod Racer game with his remaining 7/8 of a credit? So remember, we did this before at the beginning of class. We did it with a picture. Now I want you to do it with the keep, change, flip, and using the reciprocals that we had just learned about and you were just working on in your independent practice. So remember that it was 7/8 divided by 1/4. So what I'm looking for students to do is to keep this first fraction as 7/8, changing the division into multiplication, and then flipping the second fraction, which is going to be 4/1. You can multiply straight across. 28/8. And then we can divide this by 4/4 to get 7/2, which, as students should remember from the beginning of the class, would have been 3.5 minutes of playtime. This is a way that students can see what we did with the picture before to divide and see how this can get you the exact same answer using multiplication and still come and be able to divide things out just like we did in the picture and still arrive to that same answer. Kind of reinforces what they did before and assures them that this is the correct way that we can handle and approach fractions divided by fractions. The last problem that I would give them for the exit slip would just be 3/5 divided by 4/8. And again, students would be able to keep this one the same, change this from division to multiplication, and then flipping that last fraction and reinforcing the skills we were doing today. And that would be 24/20 can divide by 4, 6/5, and that would get them the correct answer. And show that students, and this would help show that students were able to understand and complete what I had taught them and asked of them throughout the whole lesson and through the independent practice that I gave them.